Hello, hello, hello. Are you getting my voice? Hello, hello. Okay, okay. Good morning. Right. Thank you, thank you, thank you, thank you. So now, once again, welcome to SAKALAVIDYA YouTube channel. Uh, right. Today, so many members are disturbing us. We need to be very careful. So let me first. Okay. Okay. Audible. Okay. Thank you, thank you, thank you. Right. Binomial theorem. Binomial theorem. Part 3A. Because yesterday there was a lot of disturbance in my class. That was due to happened by the others. It might be disturbed by others, other miscreants. Okay. So just now it got repaired. Okay, so that actually you are able to get it now. So I will repeat yesterday's class also, because only yesterday we have completed 3 problems. So then I shall start from third problem onwards. Third problem, problem number 3. So don't say 11th question, because yesterday was a lot of disturbance. I will repeat all the questions. The number of terms in the number of terms in okay the number of terms in 1 plus 5 root 2 x whole to the power of 9 plus 1 minus 5 root 2 x whole to the power of 9. X is positive, x greater than 0, is first option 3, second option 5, third option 4, fourth option 6. Okay, so now the number of terms in 1 plus 5 root 2 x whole to the power of 9 plus 1 minus 5 root 2 x whole to the power of 9 is. So that means first we need to revise the formula. Yes, okay, already over I know, but yesterday the class was not so good. The number of terms in x plus a whole to the power of n plus x minus a whole to the power of n is equals to n plus 1 by 2 if n is an odd number. Actually here n is equal to 9, which is odd. Therefore required number of terms. Required number of terms. See, required number of terms is equal to 9 plus 1 by 2. That means 10 by 2. There are 5 terms in the expansion. That means second option is the right option. Second option is the right option. Rajini Gupta already completed videos on calculus. Now, fourth problem. The number of terms in 1 plus 3x plus 3x square plus x cube raised to 6 is first option 17, second option is 19, third option 21, fourth option is 16. So this is the problem. Right, now here see this 1 plus 3x plus 3x square plus x cube is a perfect cube. It can be put in this form: 1 plus x whole to the power of 3 expansion this is. So now the solution becomes, so this can be written 1 plus x cube whole to the power of 6. One plus x cube whole to the power of 6. This equals to 1 plus x whole to the power of 18. This is x plus a whole to the power of n. So the number of terms is equal to 18 plus 1. Number of terms is equals to n plus 1. N is 18. 18 plus 1 is equal to, we have 19. So that means second option is the right option. Today is okay? Voice is audible? Everything is okay now? Right, nobody is responding. Right. So let us include some pages now. After that I will start the classes. Okay. Thank you. Perfect. Okay. Some viewers are making nuisance for us. Okay, let it be. The number of distinct terms in a plus b plus c plus d whole to the power of n. N belongs to n is the number of distinct terms. Surya Prakash, yes, all our regular viewers are there. First option n plus 3c2 n plus 3c3 second n plus 2 c3 third n plus 4 c3. This is the problem. Right. Solution. The number of distinct terms in x1 plus x2 plus x3 plus so on plus xr whole to the power of n equals to n plus r minus 1 c combination r minus 1. Here n for n, but r changes. R value is only 1, 2, 3, 4. R is equal to 4. Substitute. Now we get like this. N plus 4 minus 1 C 4 minus 1. N plus 3 C 3. That means second option is the right option. Second option is the right option. Hari Prasad Reddy. Okay. Sixth problem. The number of distinct
Tell them that they are not making money from this.
number of distinct terms in a plus b plus c plus d plus e whole to the power of 3 is first option 35, second option 38, third option is 42, fourth option 45. Fourth option is 45. Yes, Balu, exactly. Solution. Here n equals to 3, r value equal to 1, 2, 3, 4, 5. So required number of terms formula n plus r minus 1 c r minus 1. That is n means 3, r 5, 3 plus 5 minus 1, c, this will be 5 minus 1. So 7c4, 7c4 is same as 7c3. So this equals to 7c3 means 7 into 6 into 5 upon 3 into 2 into 1. 3 into 2, 6, 6 gets cancelled. So 35 is our desired answer. So first option is the right option. Seventh question. The coefficient of the coefficient of eighth term, the coefficient of eighth term in the expansion of in the expansion of 1 plus x whole to the power of 10 is first option 120, second option is 7, third option 10c8, 10c8 is equal to 10c2 also, fourth one is 210. This is the question. Okay, first the coefficient of eighth term in this expansion, that means first here n equals to 10, eighth term we need to find out, t8 equal to t7 plus 1. So general formula tr plus 1 is equal to ncr x to the power of r. N means 10, r means 7, 10c7 x to the power of r, x to the power of 7. The coefficient of eighth term, this is 10c7. So that means here we need to write coefficient of eighth term equal to 10c7. This equal to 10c3, 10 into 9 into 8 upon 3 into 2 into 1. This will be 3 3 ja and 2 4 ja. 12 into 10. 120 is the desired answer. 120. Shalamaya. Okay. Marla Venkateshwarlu, Kartikeya, Vamshi, Balu, Swati, Ishwarappa. Right. Now eighth question. Okay. Krishnamurthy, I will discuss with my son. Actually, the technical. Okay, definitely that I need to make it better. Good idea you have given. Any ideas? Please share in a Sakala WhatsApp group. Today WhatsApp group will be opened. Okay, you give the suggestions, Krishnamurthy. Good suggestion you have given. So we need to actually restrict them because they are disturbing lot of. I have been distracting. Otherwise, I am not able to deliver the correct the message, correct concept, correct content to you. My intention is actually to give the more content, more problems I need to discuss. That is my intention, but they don't have such idea. So without sweating, actually we cannot teach all these problems. Actually they don't know my work behind this one. Even I welcome them. If they want to, they need to do, isn't it? Now why should I continue? Simply I will stop. I don't want the class also. But indirectly they are disturbing lot us. That's the problem. Or else they need to keep quiet. Otherwise they need to come from, they need to open one channel, YouTube channel, for free channel. They have to give it. Can they give? They cannot. If small a and small b are the respective coefficients of x to the power of m and x to the power of n in the expansion of in the expansion of in the expansion of in the expansion of 1 plus x whole to the power of m plus n, then first option a plus b equal to m plus n, second option a equals to 2 times b, 3 equals to a equals to b, fourth option b equals to 2a. Right. So now a, b are the respective coefficients of x to the power of m, x to the power of n in the expansion of 1 plus x whole to the power of m plus n. So that means first write down here the coefficient of x to the power of r in 1 plus x whole to the power of n equal to ncr. You take the help of this basic fact. So now here solution a equals to what we can write here, n means m plus n, here coefficient is x to the power of m, see m, this equal to we can write m plus n, see m plus n minus m plus n cn, say equation 1. Now b write down, b is x to the power of n coefficient, that is ncr, r equals to n here, n for m plus n, you get m plus n cn, say equation 2. From 1 and 2, therefore a is equated to b, a equals to b. Third option is the right option. Third option is the right option. Ninth one, if the coefficients NC4 comma NC5 comma NC6 of 1 plus x whole to the power of n are in AP arithmetic progression, then n is equal to or n equals to Rajeshwari already completed, I know, but actually what happened means yesterday a lot of disturbance was there, so you might have not okay sir, yesterday we were seeing this video. Okay, no problem, right, let it be. First option 12, second option 11, third option is 7, fourth option is 8. Okay, I will explain later, Kaushik. Right, NC4, NC5, NC6 are in arithmetic progression, then n is equal to, okay, today I will do in another way. NCR minus 1, NCR plus 1. You check it. Here R value is 4. So R value is 5. 5 minus 1, 4. 5 plus 1 is 6. R in AP. Then we have that implies n minus 2r whole square equals to r plus 2. This is the shortcut. Yesterday I didn't discuss this shortcut, but if you give the provide free to think and give room to me, definitely I will explain the shortcuts also. Yesterday I left this one. Here see, n value is n only, r value is equal to this one you need to take. R value is equal to 5. Substitute here. So we get n minus 10 whole square equal to 7. One minute, I will check it. Sorry, I written wrong. Wait. The shortcut is n plus 2. 1 minute. N plus 2 right on. You simplify this one. What do you get now? N square minus 20n plus 100 equal to n plus 2. Bring this side. N square minus 21n plus 98 equals to 0. 98 factors are 14, 7 ja. Okay. Today so many frogs are joining. So many mouses are joining. What happened today I don't know. N minus 7 multiplied by n minus 14 equals to 0. Therefore n is equal to 7 or 14. Either 7 is correct or 14 is correct. So third option. Okay. Option 3. So first watch this Teja Bella, I will discuss later. Don't worry. I will discuss later. Okay. Right now, 10th question. Now this is the actually today's first question. This is the first question today. Right? If the coefficient of if the coefficient of 3rth and r plus 1th, sorry, r plus 2, r plus second terms in 1 plus x whole to the power of 2n are equal, then n equals to. Hello, are you getting? Okay, thank you. Okay, right. The coefficient of 3rth r plus 1th terms in 1 plus x whole to the power of n are equal. Okay, then we need to find out n value. First, let us write t3r, 3rth term. This we can write 3 t3r minus 1 plus 1 write down. This equal to n is 2n c3r minus 1 x to the power of 3r minus 1. So equation 1 this is. Now r plus 2 term. So tr plus 2. This we can write tr plus 1 plus 1. This is equal to 2ncr plus 1 x to the power of r plus 1. According to the problem, coefficients. So this one are equal. That means 2n c3r minus 1 equals to 2n cr plus 1. In combinations, we have studied one concept. ncr equals to ncs, then n equals to r plus s, or we can write r is equal to s also. So that means actually here you can write 3r minus 1 equals to r plus 1. This is r equals to 2. R equals to 2. I did not give the options. R is equal to 2. So now n is equal to r plus s. R is equal to 2. R is equal to 2. What is the value we need to find out now? N value we need to find out. Yes, n value. N is equal to r plus s. Okay, leave it now. We need to find out n value. So that's why, right, n equal means 2n equals to 3r minus 1 plus r plus 1. 1 cancel. This is 4r. N equals to 2r. This is the relation. N is equal to 2r. 2r is the right answer. Right. N is equal to 2r. So you can take this one. One of the options are, actually I will give the options also. Here see. First option is 2r. Second option is 3r. Third option is 3r plus 1. Fourth option is 2r plus 1. That means first option is the right option. First option is the right option. Okay, now eleventh question. The numerically greatest term. The numerically greatest term in the expansion 2x minus 3y whole to the power of 12 when x equals to 1 and y equals to 5 by 2 is. Okay. First option is 11th term. Second one is 10th term. Third one is 9th term. Fourth one is 6th term. That means which term of this expansion is the greatest term? That we need to find out. Okay. Right. So now the numerically greatest term in the expansion we need to find out. So that means given expansion, let me write 2x minus 3y whole to the power of 12. It need to be put in the form of 1 plus x whole to the power of n. So now let us take out 2x common. If we take 2x common, we get 1 minus 3y upon 2x and whole to the power of 12. So this can be written 2x whole to the power of 12 and 1 minus 3y by 2x whole to the power of 12. Now it seems to be rather it is in the form of 1 minus x whole to the power of n form. So now here this is x. Now you can take mod x, no problem. Mod x is equal to 3y by 2x. In this one, y is equal to 5 by 2 substitute and x is equal to 1 we need to substitute. That means 3 by 2 times y by x. 5 by 2, 1, 5 by 2. This is 15 by 4. So now what we need to find out for numerically greatest term? We need to find out n plus 1 mod x by mod x plus 1. But here mod x means capital mod x value. N is 12. 13 times 15 by 4 upon 15 by 4 plus 1. This is 13 times 15. 13 5 is 65, 195 by 4. This is actually 19. This will be 195 divided by 19. 19 10 ja 195 the remainder. That means you can write like this: 10 plus 5 by 19. This is P plus F form. P is the integer, F is the fractional part. Therefore NGT is TP plus 1. So that is equal to T11. That means 11th term. First option is the right option. I am reading all your comments that will be kept in your mind, but I don't reveal, I don't discuss, because the problem I will deviate from the problem. Generally, I don't have the solutions with me. Frankly speaking, I will discuss the problem here itself only. But I will go through all your comments. Otherwise, your comment will be put aside. So once again I repeat you, nobody is actually intelligent in the world. Everybody has one potential. Don't underestimate yourself. Right. So one of the actually viewers asked me this doubt. One of the viewers asked me this question, numerically greatest term. Now I explained. Yes, it is a waste of time to read comments also. It's absolutely correct. Twelfth question. Yes. 1 C0 plus 3 C1 plus 3 square times C2 plus 3 power n Cn equals to first option 4 raised to n, 3 raised to n, third 5 raised to n, fourth option 2 raised to n. Right. So now let me read the question. 1 times C0 plus 3 into C1, 3 times C1, 3 square times C2 and so on, 3n times Cn. So let it be rewritten. So now this given series can be rewritten like this. C0 into 1 plus C1 into 3 C2 into 3 square plus so on dash dash Cn into 3 power n. It seems to be rather in this form. C1 plus C0 plus C1 x C2 x square and so on Cn x to the power of n. This is nothing but expansion of 1 plus x whole to the power of n. So if you compare this one to the left hand side of this one, here x4 we have x is equal to 3. So that means now the given series, this say given series sum s is equal to 1 plus 3 raised to n, that is 4 raised to n. That means first option is the right option. First option is the right option. Right, now let us move to the next question. 13th problem. 13th problem. Yes, now we are in the track. Yes, discuss only about the problem. Don't deviate from the problem. 1 by 2 times NC0 is same as C0 only, don't worry, plus NC1 plus 2 times NC2 plus 2 square times NC3 and plus so on 2 power n minus 1 into Cn equals to first option 3 power minus n upon 2, second 4 power 2n upon 2, third one 4 to the power of n upon 2, fourth option 3 to the power of n upon 2. Okay. Right. So now here 1 by 2 is there. Take LCM 2. This can be written like this, or take out 1 by 2 common. If you take 1 by 2 common, you get like this. NC0 plus NC1 into 2 plus NC2 into 2 square plus NC3 into 2 cube and plus so on 2 into 2 power n minus 1 is 2 power n, Cn into 2 power n. It is rather standard form of a binomial theorem. This is nothing but 1 plus x whole to the power of n. So this we can write half times 1 plus x means 2 whole to the power of n. So 1 by 2 multiplied by 3 raised to n. 3 raised to n upon 2. So this is the desired answer. Fourth option. What do you want me? Vinod Kumar Bukhya. After long time. Even divide and by 2 and multiply by 2 also you will get the answer. Fourteenth problem. Right. 14th problem. 2n plus 1 C0 plus 2n plus 1 C1 plus 2n plus 1 C2 plus so on 2n plus 1 Cn. First option 2 to the power of n, second option 2 to the power of minus n, third option 2 to the power of 2n, fourth option 3 to the power of 2n? This is the question. Right. 2n plus 1 c0, 2n plus 1 c1, 2n plus 1 c2 and so on, 2n plus 1 cn. So we have one formula in coefficients we have discussed, c0 plus c1 plus c2 equals to sum of the coefficients of 1 plus x whole to the power of n expansion, that's equal to 2 power n. But here n for we have 2n plus 1. Therefore, let us say this sum is S. Therefore, required sum equals to 2 raised to 2 to the power of up to 2n, not 2n plus 1 terms, up to only n terms only. Sorry. Okay. Right. Up to n only. But right. This I will write it. Wait for a while. Okay, up to 2n plus 1 cn. 2n plus 1 cn only we have, right? Up to n after still we have how many terms we need? N plus 1 terms, n plus 1 and up to 2n terms. Next to n plus 1 we have. Okay, right. Okay, this we can write like this now. Better you say capital N. This is nc0 plus nc1 plus nc2 and so on ncn equal to, this total sum is equal to up to ncn right, equal to 2 power n. But we need nc0 nc1 plus dash dash nc small n, that's equal to 2 to the power of n by 2. Here n stands for how much? 2n plus 1. 2 to the power of 2n plus 1 by 2. That means 2 to the power of 2n plus 1 minus 1, 2n. So third option is the right option. Third option is the right option. Right. It is only up to n terms only, not 2n plus 1 terms. So that's why we need to divide by 2. 15. In 1 plus x whole to the power of 50, the value of c0 plus c2 plus c4 plus dash dash equal to, first option 2 to the power of 50, second option 2 to the power of 49, third option 2 to the power of 48, fourth one 2 to the power of 46, 2 to the power of 46. Here see solution. Here n is equal to 50. Now C0 plus C2 plus C4 plus dash dash equal to, this is nothing but sum of the coefficients of even powers of x. Even powers of x is equal to 2 to the power of n minus 1. N stands for 50. 2 to the power of 50 minus 1. 2 to the power of 49. So that means second option is the right option. Second option is the right option. Sixteenth problem. In 1 plus x whole to the power of 50, the value of C1 plus C3 plus C5 plus dash dash equals to, first option is 2 to the power of 50, second option 2 to the power of 49, third option 2 to the power of 48, fourth option 2 to the power of 46. 2 to the power of 46. Even with the help of 1 plus x whole to the power of 50 also we can find out. This is nothing but sum of the coefficients of odd powers of x. F of 1 minus f of minus 1 by 2 also we can do, otherwise 2 to the power of n minus 1. Okay. Solution: C1 plus C3 plus C5 dash dash equal to sum of the coefficients of the odd powers of x is equal to 2 to the power of n minus 1. Here n equals to 50, power is 50. So we get 2 raised to 50 minus 1. So 2 to the power of 49 is the desired answer. Second option is the right option. Mr. Sai Chandu, better to go home. Take rest. Right, thank you. Seventeenth question. C0 plus 2C1 plus 4C2 plus so on dash Cn 2 power n equals to 243. then n equals to first option 5, second option 10, third option 15, fourth option 20. This is the question. Okay, now if you observe this C0 into 1, C1 into 2, C2 into 2 square and Cn into 2 power n. So this can be written like this solution. 1 plus 2 whole to the power of n raised to 243. This is 3 to the power of n is equal to 243. 243 we need to write as the power of 3. Prime factorization. 81, 3 times 27, 3 9 ja and 3 3 ja. 243 equals to 1, 2, 3, 4, 5. 3 raised to 5. So 3 to the power of n equals to 3 to the power of 5. Therefore n equals to 5. First option is the right option. First option is the right option. Okay. 18th question. 18th. Right. One by 2 times into 10C0 minus 10C1 plus 2 times 10C2 minus 2 square 10C3 plus so on dash dash 2 to the power of 9 times 10C10 equals to first option is 1 upon 2, second option is 1 upon 4, third option is 3 upon 2, fourth option is 1 upon 3. Multiply both numerator and denominator with 2, or you can take out half common. You will get the answer. Solution now. If you take half common, you get like this. 10C0 minus 10C1 times into 2. 2 means here x. Next 10C2 2 square x square minus 10C3 2 cube and plus dash dash 10C10 2 to the power of 10. This is nothing but, this seems to be rather 1 minus x whole to the power of n expansion. N stands for here actually how much? 10. X means 2. So this we can write now half times 1 minus 2 whole to the power of 10. 1 by 2 times minus 1 to the power of even. Minus 1 to the power of odd is minus 1. Minus 1 to the power of even is plus 1 by 2 times 1. So 1 upon 2. First option is the right option. Generally, You will put answer. If option is 0, you will write option 0 because plus or minus is there. Okay, next. 19th question. 1 plus NC1 plus NC2 plus NC3 plus so on NCN whole square upon next 1 plus 2nC1 plus 2nC2 plus 2nC3 plus dash dash 2nC2n equals to right. First option 1, second option -1, third option is 1, third option is 0, fourth option is first option 1, second option -1, third option 2, fourth option is 3. Okay, so now 1 plus NC1, NC2, NC3, NCN means this 1 is nothing but C0. C0 plus C1 plus C2 plus C3 plus so on Cn is 2 to the power of n. Solution you can write like this. This will be 2 to the power of n whole square upon this will be 2n C0, 2n C1, 2n C2, 2n C2n means 2 to the power of 2n. This is 2 to the power of 2n upon 2 to the power of 2n. So this equals to 1. So first option is the right option. First option is the right option. Yes. Problem number 20. Right. Sum of the coefficients of 1 plus x square plus x cube whole to the power of 8 is sum of the coefficients of 1 plus x square plus x cube whole to the power of 8 is, first option 4 square, second 4 cube, third 4 power 6, fourth 4 to the power of 8. This is the question. Right. Are you getting now? Okay. Right. Sum of the coefficients of, so that means first let us say f of x equals to 1 plus x square plus x cube whole to the power of 8. Sum of the coefficients sum of the coefficients is equal to f of 1 equals to 1 plus 1 whole to the power of 8. This equals to 4 to the power of 8, 4 raised to 8. Fourth option is the right option. Okay. 21st. Question number 21st. Okay, bye. Question number 21st. Sum of the coefficients of x plus 2y plus z whole to the power of 10 is first option 4 to the power of 5, second is 5 to the power of 4, third is 4 to the power of 10, fourth is 10 to the power of 4. Even though the expansion will have the only one variable or two variables or three variables, it doesn't make any difference. In the place of each variable, put x is equal to 1, y is equal to 1 and z is equal to 1, because here we have the three variables. These three variables are being replaced by x is equal to 1 and y is equal to 1 and z is equal to 1, so that we get the sum of the coefficients. So here, say like this, let us say f of x comma y comma z, x plus 2y plus z all to the power of 10. Sum of the coefficients. Sum of the coefficients equals to f of 1 comma 1 comma 1. That is 1 plus 2 plus 1 raised to 10. This we can write 4 raised to 10. Third option is the right option. Next question. 22. 22nd question. Sum of the coefficients of terms of even powers of x. Even powers of x in 1 minus x plus x square minus x cube all to the power of 7 is the sum of the coefficients of the terms of even powers of x in 1 minus x plus x square minus x cube all to the power of 7 is first option minus 2 raised to 17, second 2 raised to 17, third 2 raised to 13, fourth one minus 2 raised to 13. Okay, right. So now sum of the coefficients of the terms of even powers of x in this expansion. So first let us say f of x equals to, because there is only one variable, 1 minus x plus x square minus x cube raised to 7. Find f of 1 and f of minus 1 also. F of 1. Let us find out f of 1. 1 minus 1 plus 1 minus 1 raised to 7. Here 1, 1, 1, 1 gets cancelled, 0. Now f of minus 1. 1 minus of minus plus 1 and plus 1 and plus 1 to the power of 7. This is 4 raised to 7. We have required sum of the coefficients of the terms of even powers of x. F of 1 plus f of minus 1 by 2. This 4 to the power of 7 you can write 2 to the power of 14, because 2 square all to the power of 7 is 2 to the power of 14. 2 to the power of 14 upon 2. This is 2 power 1. 14 minus 1 is 13. 2 raised to 13. Third option is the right option. Third option is the right option. Twenty-three. Right. Sum of coefficients of terms of odd powers of x in 1 minus x plus x square minus x cube whole to the power of 9 is first option minus 2 to the power of 17, second option 2 to the power of 17, third option 2 to the power of 13, fourth option 2 to the power of 12, 2 to the power of 12. Okay, so now the sum of the coefficients of the terms of odd powers of x in this expansion we need to find out. That means f of 1 minus f of minus 1 by 2. So first consider function here f of x 1 minus x plus x square minus x cube whole to the power of 9. F of 1 minus 1 plus 1 minus 1 to the power of 9. This is 0 because 1 gets cancelled, plus 1 minus 1 gets cancelled. Next, f of minus 1 plus 1 plus 1 plus 1 whole to the power of 9. This is 4 raised to 9. 4 means 2 square. This will be 2 power 18. Now required sum. Required sum is equal to here odd f of 1 minus f of minus 1 by 2. 0 minus 2 to the power of 18 by 2. This will be minus 2 to the power of 18 minus 1, 17. So first option is the right option. First option is the right option. Twenty-four. The range of x for which the expansion the expansion 9 plus 25x square whole to the power of 9 plus 25x square raised to minus 6 by 5 is valid when first option minus 3 by 5 upon 3 by 5, second is closed minus 3 by 5 comma 3 by 5, third option minus infinity comma 3 by 5, fourth option is minus infinity to 3 by 5 union, this is minus 3 by 5 to infinity. These are the options. Okay. Right, let us check now. Here the range of x we need to find out for which the expansion is valid. See, this 1 plus x whole to the power of n, when n is not a integer, is valid when mod x is less than 1. That means minus 1 less than x, x less than 1. You remember this one. First, that means you need to write this expansion as in this form. So take actually 9 common here. If you take 9 common, this can be written 1 plus 25x square upon 9 raised to minus 6 by 5. Here x important. X is actually here 25 by x square upon 9. This will be, so 25 by x square by 9 is less than 1. That implies here x square is less than 9 by 25. So that means x is less than, mod x is less than 3 by 5. That means minus 3 by 5 less than x, x less than 3 by 5. Therefore, x belongs to open minus 3 by 5 comma 3 by 5. In this interval only it is valid, expansion is valid. First option is the right option. Twenty-fifth question. 25th question. The coefficient of x to the power of 7 in 1 plus 2x plus 3x square plus 4x cube plus so on dash dash infinity is first option 0, second option 6, third option is 8, fourth option 36. See, if you observe the problem, this 1 plus 2x plus 3x square plus 4x cube dash dash infinity is the expansion of 1 minus x whole to the power of minus 2. See, solution we have. See, this 1 plus 2x plus 3x square plus 4x cube plus dash dash plus r plus 1 x to the power of r dash dash infinity is equal to 1 minus x whole to the power of minus 2 expansion. Here we need x to the power of 7 coefficient. That means r value must be 7. So therefore x to the power of 7 coefficient is equal to, actually we need to take r plus 1 here. R plus 1 means 7 plus 1 equal to 8. So third option is the right option. Third option is the right option. Who is Mr. Tanikonda Tippatti Swami? Today so many new members are coming. Right. Ah yes, derivatives only. Right. Next 26th. 26th. 1 minus 1 upon 5 plus 1 into 4 upon 5 into 10 minus 1 into 4 into 7 upon 5 into 10 into 15 and plus dash dash infinity is equal to dash dash infinity is equal to first option 1 by 3 times cube root of 5, second option 1 by 2 times cube root of 5, third option 1 by 2 times cube root of 4, fourth option cube root 5, cube root 5. This is the question. See, first let us say like this, S is equal to 1 plus minus 1 by 5 write down, this is plus 1 into 4, this is 5 into 2 write down, 2 factorial into minus 1 by 5 whole square write down, plus this is 1 into 4 into 7 by 3 factorial 6, this write down minus 1 by 5 whole cube and dash dash infinity. This can be put like this, here 1 by 1 factorial. So comparing with 1 minus x whole to the power of minus p by q, 1 plus p by 1 factorial times x by q plus p into p plus q upon 2 factorial x by q whole square plus dash dash infinity. See, here we can write p stands for 1, p plus q stands for 4, that means q equals to 3. Now x by q is equal to minus 1 by 5, that implies x is equal to minus 3 by 5. So we need to find out s is equal to this one, s equals to 1 minus x whole to the power of minus p by q. So that is 1 minus x, 1 plus 3 by 5, because minus of minus plus minus p by q, minus 1 by 3. This will be 8 by 5 whole to the power of 1 by 3, minus 1 by 3. This we can write 5 by 8 whole to the power of 1 by 3. Right? This equals to 5 to the power of 1 by 3 means cube root 5. 8 to the power of 1 by 3 means 2. So 1 by 2 times cube root 5. This answer. Okay. It's very easy problems actually. We can find out like this. Okay, next. So I will give the notification for the evening classes through WhatsApp group. Okay. So I don't put the notification here. So today I was somewhat distracted because alternate plus and minus are. Okay, no problem. Always, generally I take only, you might have observed my classes, generally I use only one formula. More formula I don't use Narla. For minus, for plus, I don't use the two formula. Only one formula applicable for all. We'll get the answer. Right. Thank you one and all. Bye. See you. So I'll give the notification through, today onwards I will give the notification through WhatsApps only. Please go through the WhatsApp group. That's all. Thank you.